Hi everyone, my name is Asutosh Jadhav and I am a final year student in Electronics and Telecommunication Engineering department. Today I will be walking you through an important topic in the field of networking, virtualization and its applications. This concept is not only relevant in theory but also widely applied in real world technologies like cloud computing and enterprise networks. So, what exactly is network virtualization? Think of it like creating virtual versions of physical network components such as switches, routers, and firewalls using software. Just like how we virtualize a computer into multiple virtual machines, we can now virtualize entire networks. This means and instead of dealing with tangled cables and static connections, we can now create, modify, and manage networks entirely in software, making networking more dynamic, flexible, and scalable. Let's look at the two primary types of network virtualization. First, external network virtualization. This type combines multiple physical networks into one cohesive virtual network. For example, multiple branch offices can be connected over a unified virtual network using VPN. Second, internal network virtualization. Here, we simulate networks within a single physical device, such as a server. Virtual machines on this server can communicate over a virtual switch, just like they would in a real network. This is especially useful in data centers. The backbone of network virtualization includes both hardware as well as software. Hardware like routers and switches provide the base layer. Network services such as firewalls, intrusion detection, and load balancers are abstracted. Virtual machines or containers connect to these networks. And most importantly, SDN, software-defined networking, plays a critical role by offering centralized net control and automation. Now, how does it actually work? It starts by abstracting physical components using a hypervisor. Multiple networks can run on the same physical infrastructure. SDN controllers act like the brain of the system, managing traffic, rules, and connectivity. We also use techniques like VLAN and VXLAN to logically segment the network for performance and security. The benefits are significant. You reduce dependency on expensive physical hardware. You gain the scalability to easily add or remove resources. It simplifies complex network topology. You get better resource utilization and energy efficiency. And lastly, it improves security by isolating network traffic for different applications or tenants. Applications of network virtualization. This technology is being adopted rapidly across industries. In cloud computing, it allows the creation of virtual private clouds and seamless user scaling. Data centers rely on it to optimize storage, computing, and networking. Developers use virtual networks to test applications in isolated environments. In educational and research labs, virtual networks reduce setup costs. Enterprises use them to deploy network services without touching the physical infrastructure. Here are a few platforms making network virtualization a reality. VMware NSX allows you to run secure virtual networks over physical infrastructure. Cisco ACL helps in ACL helps in automating and securing large-scale enterprise networks. Microsoft Hyper-V lets you create virtual networks within Windows environments. These tools show how virtual networks are already mainstream in the IT world. Of course, there are challenges too. Complex configurations during setup, ensuring security across a virtualized environment, compatibility issues within older hardware or legacy systems, and sometimes a slight performance overhead due to abstraction layer. However, with advancing technology and better software, many of these issues are being addressed. The future of network virtualization is bright. It's going to play a key role in 5G networks by enabling splicing and dynamic resource allocation. It will enhance IoT networks, allowing devices to communicate securely and efficiently. The integration of AI ML will further automate traffic handling, fault detection, and optimization. In short, it's the foundational block for future digital infrastructure. To wrap up, network virtualization is changing how we build and manage networks. It's making them more flexible, scalable, and efficient. Whether it's cloud computing, data centers, or smart networks, this technology is paving the way for next-gen communication systems. Thanks a lot for watching this video. That's it.